A great deal of spatial analysis is concerned with the geographic location of phenomena in relation to other similar features or compared to other different features. You learn a lot by exploring relationships between features within layers or even between different layers. So much of spatial analysis is concerned with understanding information by location, effectively understanding how much exists at a place. You might want to look at the number of businesses along a freeway, the length of a river within a watershed, or the number of people living within 24 hours of Tulsa. Using descriptive statistics, you can derive summary measures that help you gain a real understanding of the data. You can report quantitative descriptions that can be conveyed clearly. A large amount of data can be distilled into simpler summaries that show the basic characteristics of that data. In fact, many data are already summarized or aggregated to areas, such as census data, like population data. These can also be reported as a percentage value for the area, such as the percentage of under 18-year-olds, or as an average, such as the average income. In other cases, individuals may be impractical or even unavailable for you to use, or you may not be able to use individual data because of data confidentiality. So then you need to find a simple descriptor that's an aggregate for that area. GIS gives you the tools that allows you to easily aggregate or summarize data. You can summarize data to any location, find what's nearby or what's within. You might find the potential customer base near a proposed store, the number of auto thefts within a police beat, or the total acreage of deforestation within a watershed. Using GIS, you can use spatial data to create new data sets. Spatial data can be of the same or of a different type and can be combined and used to look at associations, for example, between exposure and disease, combining polygon data with point residential locations, or between crop yields and soil type, combining polygon with polygon data. So you can use any data that has a geographic reference. So you can use data from many different sources to combine them to create new information. Combining data can be done using attribute information, as long as you have data that's common in both of the data sets you wish to join. So if you have an attribute, a field that holds the same information, you can join that together. But more uniquely to GIS, you can combine using location itself. Data is often combined using overlay analysis. Overlay is the analytical process of stacking spatial data on top of each other and processing that combination of spatial features and the attribute data to create a new layer. Multiple layers can be overlaid, the geometry can be modified, and new output created. You can find new areas that have the characteristics of all the input data, and we'll cover a lot of those approaches in next week's lecture. Vector overlay estimates the geometric intersection of multiple data sets of either the same type or different types of geometry, combines them to create a new output data set. There are many different types of overlay techniques, each of which uses a different spatial relationship to determine the result. Many of the terms are analogous to Boolean logical operators, such as and, or not, and use the logical relationships that we see within a Venn diagram or a set diagram. So remember those maths lessons that you sat through at school that you thought you were never going to need? Well, now they're going to be useful to you. So for example, intersection is analogous to the Boolean logical operator of and. The geometric intersection of the input features is calculated, and only those elements common to both those input layers that overlap are part of the output layer. Union is analogous to the OR operator, and all the elements from both input layers will be present in the output layer. One of the huge advantages that spatial analysis brings is the ability to combine data from multiple different sources, combine them into a common framework for analysis.